Good evening, ladies and gentlemen. This is the second half of the piecewise functions. We did graphing to begin with. You can see all the stuff that we did before. Now we're going to write an equation for piecewise functions. So we're going to do something like this. F of x equals, and then a piecewise function. Now this particular piecewise function, there's three parts to it. So we got to do each of these different parts and then the constraints also. So I'm just going to do this first one left. There's a couple different ways you can do this. This first one looks like it has a constraint at x equals 0. Basically all this graph right here is all the x values, like here it's -1, -2, -3, and actually 0 itself, part of the graph, are less than 0, but its x is less than or equal to 0 because it's not a circle, it's a colored in circle, filled in circle, whatever you want to call it. But the way I would figure this one out, one way to do it is I can see, I'm going to use slope-intercept form, y equals mx plus b form. I can see my y-intercept here is 1, 2. So I know it's going to be plus 2. I just got to figure out the slope. It looks like if you continue on, it kind of looks like this. It looks like we're going up 1, plus 1, and then over to the right, plus 1. It's going up as it goes to the right, so that's a positive slope. It's a slope of 1. So I could say my slope is 1, so 1x plus 2. So this first line here, I'm going to get rid of the part that is not part of that piecewise function, is y equals 1x, or x plus 2. If, and we want all the values going this way that are less than, and it's filled in so less than or equal to 0, so my constraint would be x is less than or equal to 0. Okay, for this next one, I'm going to use y equals mx plus b again. I can see it crosses the x-axis at 0, so I'll just say plus 0. It doesn't mean there's no intercept there, it just means it's 0. And once again, it looks like the slope is up 1 over 1, up 1 over 1. So 1 over 1, and it's positive because it's going up to the right, just 1x plus 1. So really that simplifies down to y equals 1x, or just x, y equals x. So I'll put that right here, y equals x. Now the constraints for this one, it looks like right here, this constraint, that's x equals 0, or in this case it's going up, it's greater than 0. So I'd say x is greater than 0. It's an open circle. 1, 2, 3, looks like right here x is equal to 4. So it goes up to 4, but it doesn't go past 4. So it's greater than 0, and x is less than or equal to, because it's colored in here, 4. So it's between 0 and 4. One way to write that is with the compound inequality going from smallest to largest. I got 0 here, I got 4 here, and x. It's less than or equal to 4, and it's 0 is less than x. This part right here, x is less than 0. If you flipped these around and put 0 first and then x, you'd have to change greater than to less than. So that's why that piece goes right there. If it's in between two, this is generally how you'd write your constraint as a compound inequality. Okay, one other way to do this, I can see my slope here is going to be 1 again, but I'm going to show you how to do this a little bit differently by picking just a couple points. Now, its starting point for this last one here, well, this is x equals 4, so I'm just going to use that point. That point there is 1, 2, 3, 4, and then up 1, 2 is the ordered pair point 4, 2. So just using ordered pairs and then writing linear equations from that. I'll pick this point also. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. So 6, 4. Okay? And if you didn't know the slope, this is how you do it. Slope is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So my y value is 4 and 2. I'm going to say 4 minus 2. And then my x values, 6 minus 4. I'm going to get 2 all over 2, and that's equal to 1. And we No, it goes up 1 over 1. We know our slope is 1. I'm just showing you that you can do it this way. Now, using one of these points, and I'll just use the point 4 too. I'm going to plug it into slope-intercept form here. Y equals mx plus b. We don't know our y-intercept b. We could figure it out, but I'm just showing you how to do it by using ordered pairs. I'm going to plug this in for x and this in for y. So y is 2 equals, we just found our slope to be 1 for m, and x is 4 plus b. So 2 equals 4 plus b. And then just solving for b, you'd subtract 4 from both sides. 2 minus 4, that means b is equal negative 2. Okay? So, what does that mean? Slope is 1, y-intercept's negative 2. My linear equation is y equals 1x, or just x, so minus 2. Now, it starts at this point right here. That's where x is equal to 4. We want all the values for our constraint where x is greater than 4. If it was colored in, it'd be greater than or equal to 4. Here's my x value 5, 6, 7, and so on. So if x is greater than 4. So it goes from 0, less than 0, to between 0 and 4, and then finally just greater than 4. So if you're doing domain and range for this, your domain would be all reals, and it looks like this is going up and this is going down, so all your y values are covered. Your range would also be all reals. Okay, just two pieces here. They give us the ordered pairs, so you could do it the way we just did it. So I'm just going to say this. Get it started off, f of x. Use that little symbol for putting our piecewise function together. I can see my y-intercept right there is 1. My slope, it's going up 1 over 1. So slope is up 1 over 1. That's slope of 1. 1x, and my y-intercept is 1. I'm just going to say this. Y equals 1x, or x plus 1, if, oh, where's our constraint? It looks like right there. This dotted line is x equals 1. Now, this part of the line is going to the left, so you want your values less than 1. I'm just going to say x is less than 1 for my constraint because it's an open circle here. Okay. This one, I could just use the points 3, 2, and 1, 1, or 1, 0 here. But I can see this kind of goes down. I can see my y-intercept is going to be negative 1. Our slope, again, is up 1 over 1. So we could write it that way. I'm just going to use the points again to kind of show you, to make sure we solidify that route 2. So I'm using 3, 2, and 1, 0. So first of all, finding the slope. Y sub 1, sorry, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. It's basically that you subtract the y values, you subtract the x values, and that's your slope. So 2 and 0 are my y values. 3 and 1, I'm going to get 2 over 2. Once again, my slope is 1. We already found that, but just showing you how to do that. Y equals mx plus b. We want to find b. I know it's going to be negative 1, but just showing you how to do it. Let's just pick the point 3, 2. This will be my x. This will be my y. So I'm going to plug in 2 for y, 1 for the slope, this 3 right here for x, plus b. This is 2 equals 3 plus b. So if you subtract 3 from both sides, obviously, b equals negative 1. So, our y-intercept's negative 1, our slope is 1, so it's y equals 1 for my slope, 1x, minus 1. And the last thing is just the constraint. It kind of picks up where this one left off, and that's at x equals 1. It is colored in here, so 1 is part of the solution. I want all the values of x going to the right, which are greater than 1. So I'd say my constraint is x is greater than or equal to 1. There we go. That's how we take a piecewise function and then write the function notation for it. Okay, I want to evaluate this piecewise function at some values here. First one is a f of negative 3. Now what that means is I'm going to plug negative 3 in to this function. I don't plug it into both of them. I have to figure out which one I plug it into by looking at the constraints. This first constraint is x is less than 0, so basically those are my negative numbers. This one is x is greater than or equal to 0, so if I had 0, I'd plug 0 in there, or 1, 2, 3 positive numbers. So I'm going to plug this one in to the first one. So it's going to be f of negative 3, because it's less than 0, negative 3 squared minus 1. I'm basically plugging it into this function right here and just evaluating it. Negative 3 squared is not negative 9. Negative times negative is a positive, so that's 9 minus 1, or 8. 8 is my answer here. So a couple different ways I can write it. You can just say, hey, 8's my answer, or f of negative 3 equals 8. You can also write it as an ordered pair. Our input variable is our x value. Our output, what we get, is our y value. So that's the same as the ordered pair, negative 3, 8. And you can graph that if you wanted to. Now we're going to find f of 2. Well, 2 is greater than 0, so I'm going to be using this function right here. I'll just plug it right in, right? 4x plus 1, so it's 4 times 2 plus 1. That's 8 plus 1, or 9. Now you could just say, hey, the answer is 9. Or you could say, right as an ordered pair, you input an x value of 2, f of x is your output, or y, so that's 2 comma 9. Okay? Last but not least, this f of 0. Now both of these deal with 0, but the first one is less than, the second one's greater than or equal to, so we can use 0 and plug it into this function. And that's going to be 4 times 0 plus 1. 4 times 0 is 0, 0 plus 1 is 1, 1's my answer. Or you could say it's the ordered pair, 0 comma 1. Okay, here we go. Just practicing this a little bit. First of all, you got to figure out which function you're going to plug it into. 2x, or 2/3 x plus 4, y equals 3, or negative x plus 1. The first part here, our constraint is x is less than 0. Well, negative 6 is less than 0, so I'd use this function right here. And that's going to be 2/3 times negative 6 plus 4. 3 goes into 6 negative 2 times. Negative 2 times 2 is negative 4 plus 4. You're going to get 0 here. Now you can do this on your calculator also. Just plug 2/3 in parentheses and multiply it by 6. Use parentheses when you're working with fractions, and you're still going to get, it's negative 6 actually, negative 4. So I'd say my ordered pair is negative 6, comma 0. Equals 0 right here. Now, this is going to get a little complex. This one is less than 0, so I can't use this one. Here it's 0 is less than or equal to x, so you can use this graph. Now, this function here is y equals 3. Basically, no matter what you plug in for x, you're going to get 3 as an output. So when I find f of 0, I'm not plugging it in for any x. That's just going to give me 3. So when x is 0, y is 3. Right there. Wouldn't matter if I plugged in. Okay, there's 2 zeros there. Should be 3. We'll skip that one. We're going to go down to 5 here now. 5 is greater than or equal to 3, so I'm going to plug it into this function. So it's negative x, and x is now 5, plus 1. So negative 5 plus 1, or negative 4. You could just write negative 4 as your answer. That would be fine. But if you're writing it as an ordered pair, my input x is 5, comma, my output y, or f of x is 4. 2, this is a good one. Because 2 is not greater than 3, it's not less than 0, it's in between 0 and 3, so we're using this function again. Now that function is basically y equals 3. So it doesn't matter what you plug in for x, y is always going to be 3. So f of 2 equals 3. There's no x to plug it into. So when I put in 2, I get 3 as an output. I'll let you guys try number 10 on your own. You should get -9, so go ahead and try that. That's about it for this part of the lesson. So peace out, Boy Scout.